Hello, sixth graders. We're back with lesson 6, using and comparing ratio representations. Just a reminder, if you're working in OneNote, we're in the M2-T1 ratios tab. You're looking for the one labeled 1.6, using and comparing ratio representations. It's titled 1 is not enough. If you're working in the textbook, I need you to find M2-85 to follow along from there. All right, let's get going. 1 is not enough. Learning goals. We are going to use graphs, which we learned in the last lesson, to compare ratios. And we're going to read and interpret graphs, double number lines, and tables to help us solve problems. Let's skip our getting started this time, and I want you to go to activity 6.1, comparing ratio graphs, M2-87. It says the adult ticket price for admission into the Rollerville amusement park is $15. An amusement park sounds so fun. I wish we could go there right now. The table and the graph show the ratio of number of adult tickets to cost. So you can see one adult ticket is $15, 2 of them cost $30, 3 for $45, and 4 for $60. We can also see it graphed over here to the right. And you can see the amount of each ticket price by the plotted point. 1 for 15, 2 for 30, so on and so forth. The Rollerville amusement park has different charges for students and for preschool children. Student tickets are $10 and preschool age children tickets are $5. It says complete each table and then plot them. Why don't you pause me for a second and see if you can fill out these tables and then join back here as soon as you can to see if you got them right. Okay, hopefully you were able to come up with the student ticket. One student ticket costs $10, 2 of them would cost $20, 3 would cost $30, and 4 would cost $40. For the preschool tickets, 1 is $5, 2 of them would be $10, 3 would be $15, and 4 would be $20. Okay. Then it says to plot each set of equivalent ratios on the graph. Use a triangle for the student tickets to the cost and use a square for the preschool tickets. Okay, let's do the student tickets first. And I'm going to stay in my blue pen so we can keep them separated. So one ticket costs $10, so my dot will go right there. 2 costs $20, so that dot goes there. 3 for $30. I'm going to zoom in here just a little bit. And 4 for $40. Now let's change the color and let's put in our preschool tickets. We can get 1 for $5, which would be there. 2 of them would cost $10. 3 would cost $15. And 4 would cost $20. Okay, it says, draw 3 separate lines through the points that represent each ratio. What do you notice? Let's do that to the best of our ability. So our preschool line. And let's go back to our blue for our student line. Okay, I got a shaky hand today, I think. And for our adult ticket line. All right. What do you notice about the graphs? I notice that they all go through the origin. I notice they're all a line, which means they're equivalent ratios. I better write those things down. They'll make a line. They'll go through the origin, or 0. Goodness sakes. I also notice they're not all the same steepness. Okay, I'm going to write that down. Not all the same steepness. Okay, next question. Do all the points on the lines that you drew make sense in this problem or situation? Why or why not? Would they all make sense? Well, let's look. Can I have 1.5 tickets or 2.5 tickets? I can't have a fraction of a ticket. I don't think that gets me anything. I have to have a whole ticket for no matter what the age is. So yeah, not every single one is going to make sense. So let's write, let's say no, because you can't have a fraction of a ticket. You can have a fraction of money, but you can't have a fraction of a ticket. And number 5, how can you tell by looking at the 3 lines which cost to ticket ratio is the highest and the lowest? So which one would you say is the highest cost to ticket ratio and which one's the lowest? Well, I think we can see the highest one would be the one that's the most steep, and the lowest one would be the one that's least steep. So how can you tell? Let's say the steepest line represents the highest cost to ticket ratio. Good. All right, let's move on. Activity 6.2. We'll do this one. It says, you know different ways to think about ratios, so you can use different strategies to help solve problems. Let's try. The graph shown represents the number of gallons of water used for the number of times a toilet is flushed. Okay. Part A says, write each point on the graph as a ratio of gallons of water used to number of flushes. Okay, so gallons, let's see. I have to write each ratio, each plotted point as a ratio. Okay, gallons of H2O and number of flushes. If I'm going to write each ratio, I think I'm going to kind of keep it set like a table sort of thing. Okay, so let's look at these plotted points. I see here I've got, this is 5 flushes, so this is 1, 2, 3, 4. This would be 1, 2, 3, 4. So I can see that one flush is 3 gallons of water. So 1 flush, 3 gallons of water. The ratio would be 3 to 1. Okay? And I can see that this next dot would be 2 flushes, and that would be 6 gallons of water. Ratio of 6 to 2. And this next dot would be 3, and this is 6, 7, 8, 9. So 9 to 3 ratio. And finally, we have 4. There's 10, 11, 12. 12 to 4, so ratio of 12 to 4. Okay, so write each point as a ratio. So I did that right down here. Gallons of water used to the number of flushes. What do you notice about each of these ratios? 3 to 1, 6 to 12. Let's see, 3 to 1, 6 to 12, 9 to 3, not 6 to 12. Goodness, I hope I'm playing Catch My Mistake, and you figured that out. And 12 to 4. Well, I do notice here that if I was to simplify each of these, I would get a 3 to 1 ratio. All right, so they are all equivalent. I can see that right there, that they're all equivalent because they all simplify down to 3 to 1. C says, how many gallons of water would be used if the toilet was flushed 8 times? And it says, explain the method that you used. All right, so I could use this graph if I want. If I'm liking how I like the graph, I could do a table more like what I just did. I could do a double number line. I could do a picture. I could do a tape diagram. I have lots of different methods. So go ahead and try whichever method you like for C and D, and then try to answer E. So go ahead and pause this and try to answer those, and then let's come back and chat about it. Okay, whatever method you chose to use, I'm going to stick with, I think, the table right now. When I'm looking at how many would it be flushed in 8 times? 8 times. Well, if 4 times yields 12, I'm just going to multiply 4 times 2 to get 8, and 12 times 2 to get 24 gallons. So 24 gallons. And I used a table, and I actually scaled up. Okay. Oops, that was the answer for C. I'm going to have to flip-flop these guys. All right. D, it says, how many times would the toilet be flushed to use 18 gallons of water? 18 gallons of water. Let me see if this graph will be helpful for me. Let's go. That's 15, 16, 17, 18 gallons would be there. And if I notice that every single time I am just going, will that help me or not? I could use the fact 18. I could double 9, because I know 9 times 2 is 18, and I could double this to get 6. I think that might be the strategy that I use. So let's see, 18 yields 6 flushes. So this is the question I'm actually answering. 6 flushes uses 18 gallons of water. It says, did you use the same method to answer each question? And if not, why? Now, you might have a totally different answer than me. I guess in both instances, I used the chart because I found it to be the easiest to find something exact to multiply by. You may have used the graph. You may have made a picture or a tape diagram or a double number line to help you. But for me, I think just using the numbers and figuring out what to multiply them by makes the most sense for me. Let's try one more like that. I want you to pause this now, and I want you to try to answer to A, B, C, D, and E, and see if you can use those strategies. We just practiced another one to solve this problem. Go ahead and pause the video, and then come back as soon as you have answers to those questions. Okay, hopefully we're back and you've got some things written down here. It says the graph shown represents the number of gallons of water used for the number of loads of laundry wash. Man, we're using lots of water today, flushing toilets and washing clothes. It says write each point on the graph as a ratio of gallons to water used to numbers of loads of laundry. All right, so gallons to laundry. That's what our ratio is going to be. So when I zoom in here a little bit, just to make it easier to see, I can see that this one, again, 1, 2, 3, 4, 5. I can see two loads of laundry, and this is 11. Oh, this must go up by 2. So 12, 14, 16, 18. So 2 loads of laundry yields 18 gallons. Okay, next one listed 3 loads of laundry yields, it's 22, 24, 26. Ooh, it looks like it's pretty much in the middle of there, so I think I'm going to call that one 27. So 27 to 3. And then we have 4 loads of laundry. And here we have 32, 34, 36 to 4 loads of laundry. What do you notice about each ratio? Okay, each ratio. Well, the denominators each differ by 1. What else? I'm wondering if I simplify these. What do they simplify down to? 18 divided by 2 is 9 to 1. 27 divided by 3 is 9 to 1. And 36 divided by 4 is 9 to 1. Okay, so again, they are all equivalent. That's what I notice. How many gallons of water would be used for 7 loads of laundry, and explain the method that you used? Okay, so 7 loads of laundry, 6, 7, that would bring me up here. 7 loads of laundry. I don't know where my dot is exactly, so I don't know if my graph's going to help. I think better for me, now that I know that this simplifies down to 9 to 1. And if I want to know how many for 7 loads, I could scale up. So I could do 9 times 7 is 63. So I think my answer is 63 gallons for 7 loads of laundry. I also could have combined what it took for 3 loads and 4 loads, because 3 loads and 4 loads is 7 loads. So I could do 27 plus 36, and I could get 63 that way. 3 plus 4. Either way, 63 gallons of water used. So again, I'm going to prefer that we stick with the multiplying because the graph doesn't necessarily always help me. How many loads of laundry can be done if 45 gallons of water are used? 45 gallons. So I think I'm going to take what I know about this one, 9 to 1. And I have to have 45 gallons, so I scale up. And if I scale up on that, I scale up on that. And so then I know that I can get 5 loads done. I also could probably have drawn my line on here. If I don't always need an exact answer, the graph can sometimes be helpful as well. So on here, my answer, what did I get? 45 for 5 loads. So let's see if I intercept all the way up here. be right about there. Would that be about 45? That's 42, that's 44, and yes, that would be about 45 loads of laundry. So I could use my graph to help me with that one as well. Finally, did you use the same method to answer each question? You go ahead and answer that because everybody is a little bit different. I kind of stuck with the same strategy. All right, one last activity. This just has us making some observations. Still sticking with the water theme. Shower heads come in various styles and allow for different rates of water to flow. The ratio of gallons of water to time is given for 3 different shower heads. Now, you might be asking yourself, who cares, right? But we have to pay for water each month. That's part of our utility bill. And if your parents are paying the bill, they want the one that's going to cost the least, right? And so if you can have not as much water coming out each time per minute, you don't have to pay as much. So it can be helpful to make some of these comparisons. So the first shower head uses 20 gallons of water for 5 minutes. So you can see they put that on there, 20 gallons for 5 minutes. And they put in some various other amounts, 4 gallons for 1 minute, 40 gallons for 10 minutes, 56 for 14, 60 for 15, 88 for 22. You can see the second shower head type uses 25 gallons for every 10 minutes. And they put that one on here, right here, 25 gallons for every 10 minutes, and plotted a few other points on here as well. 10 gallons for 4 minutes, 2.5 gallons for 1 minute, 35 for 14 minutes, 37.5 gallons for 15, so on and so forth. And then finally, the last one says the third shower head uses 8 gallons for every 5 minutes. And they put that on there, 8 gallons for every 5 minutes. Then they went ahead and added some other numbers on their double number line. That's 1.6 gallons for 1 minute, 11.2 gallons for 7 minutes, 16 gallons for 10 minutes, so on and so forth. So the 2 questions that they're wanting us to answer: which of the 3 shower heads uses the least amount of water per minute? Per minute. This is key. Per minute has us talking about something called unit rates. If you go to Menards and you're shopping for these shower heads and all you see is 20 gallons for 5 minutes, 25 for 10, and 8 for 5, you might have a hard time of deciding which one is the best, which one's the most efficient amount of water per time. So what you need to find out is the unit rate. The unit rate is comparing all 3 to 1, right? Getting one of those variables, one of those ratio components down to 1. So in this question, it says, which of the 3 shower heads use the least amount of water per minute? So they wanted the ratio to be how much per minute. They wanted the ratio down to 1. Well, if you look at the double number line, they were able to show you per minute, per minute, per minute. Now, which one of these has the least amount of water per minute? Hopefully, you said this last one. It only emits 1.6 gallons per minute as opposed to 2.5 and to 4. We can use these double number lines. We plotted our initial amounts and we can get them down to 1 on all 3 of them to figure out what the unit rate is to find the best deal. That leads us into our next lesson on unit rates. That's where we're going to end today in comparing ratio representations.